Hello everyone. We did the Practice AMC10 paper a few days ago, and so for this video I'll be doing the Practice AMC12 paper. The Practice AMC12 is in the same format, so if you haven't seen the previous video, basically I am just taking the practice contest on AoPS. This is free, and this is something that you can also attempt if you would like to. I've included the link in the description below, so if you'd like to give it a try first, feel free to do so. Once again, for those of you who are taking the AMC on an online platform, there is a chance that you'll be seeing something that is somewhat similar to this for the actual AMC this year. If you're taking on pen and paper, of course you will not be seeing all of these. However, the instructions are still going to be the same. You're allowed to use your usual writing materials, rulers and compasses, but no calculators, protractors, and graph paper. During the previous AMC10 video, what I did was I copied over the questions into a Word document in order to discuss them. I will still roughly do the same thing, but because the AMC12 is a little bit harder, I think I will not be able to spare as much time. So what I'll do is that for the first 5 questions, I will try to do it mostly mentally, or at least just describe my thoughts out loud. I will not be copying it over or writing out any workings. This is going to be a speed run. I don't know if I'll finish, but I definitely need to move quite quickly. The AMC12 is, as we are highlighting, 25 questions, 75 minutes in ascending order of difficulty. So if I want to finish the paper, I should be done with the first 10 questions in under 15 minutes and the first 15 questions in under 25 minutes. That's usually what I would be aiming for. They keep asking me whether I'm sure. Yes, I am sure. So let us start. Okay, question 1. So just divide. The swimming is 0.2 miles at 12 miles per hour. 12 miles per hour just means 0.2 miles per minute, so 1 minute. The 6 miles of flying in 40 miles per hour. 40 miles per hour means 2 miles in 3 minutes, so 6 miles in 9 minutes. That's 10 minutes so far. And then 5 miles, 1.5 miles of running, that is 0.3 hours, which is 18 minutes. So 10 plus 18 is 28. Second one, Little Fairy Book has this, the Big Fairy Book has this, a picture is worth 1,000 words. Okay, that's funny. This is 26,400, and this is 66,000. 66,000 is 2.5 times of 26,400, so 2.5 times of $16 is $40. Question 3. What is the probability that her third row equals the sum of her first 2 rows? Okay, so for this one, there are 6 cubed sequences, which is 216. The third row equals the sum of the first 2. If the third row is 2, there's 1 case. If the third row is 3, there's 2 cases, and so on until if the third row is a 6, there are 5 cases. And so 1 plus 2 plus 3 plus 4 plus 5 over 216, 15 over 216 is 5 over 72. Question 4. In what base does the following equation hold? It certainly does not hold in base 10. Since I'm doing this mentally, I refuse to write this out as an equation. I will just take it as base B, and in base B, the last digit, 3 times 3 is congruent to 1 mod B, which means that B is a factor of 8, which means that it is either option A or option B. Option A is wrong because 33 in base 4 is 15 and 1001 is 65. 15 is not a factor of 65, so it has to be option B. Question 5. 5 different circles are arranged as follows. Okay, so I give up. I'm not going to mentally do this. That will take more time. So this one I will copy over to the Word doc. Radius 1, internally tangent and tangent to each other in the same radius. What happened to the circle? That's weird. Where did my circles go? It's not allowing me to draw. This is not helpful. I guess this is the thing that does not really go wrong when... Oh, now everything showed up. Great. Okay. Technical issues can happen if you're doing it online, so just don't panic. Internally tangent and tangent to each other with the same radius or same size. D and E are internally tangent to A as well, and externally tangent to B and C, and have the same radius. Does it say that they're tangent to each other? No, it doesn't. It just says that they are externally tangent to A, and that means that if you're tangent to both circles, it means one's here and one's here, which is obviously a case where my first two circles are not in the correct size. Now, already if I were doing this, I think I would be inclined to just almost jump over the question, because it's taking a bit long for question 5, but I have already started drawing it here, so I have to kind of just continue trying to make this work. These do not look like the same size. Okay. It's not perfect, but I don't really need it to be perfect. It just needs to be not too crazy. Now this already looks pretty bad, but I think I've used up enough time. So essentially this, that just means that the two blue circles are supposed to be symmetric, right? Okay, so I think this is what has happened. They are supposed to be just symmetric. This is the center, and then now you draw. Okay, good. So this is how it looks like. And they didn't give a diagram. I think that's all part of making you waste a bit of time. Okay, this is R. Now the radius, therefore, if it has to be here, these are all half. And then this is the center of the circle. The center of the circle of radius 1. So this is 1 minus 2r. And then now I can just use Pythagoras on the right angled triangle. So R is 1/3. Okay, that took a bit longer than I hoped. Partially exacerbated by technical issues. Okay, let's hope that we can speed up. Question 6. Integers satisfy this. What's the maximum possible value of 3m plus n? I'm thinking of completing the square here in some form. I see that the m and the n are all quadratic, so I think it can work. I'm going to write this down as well because writing is faster. N squared is unaccompanied, so I want to do n plus 2m squared. N plus 2m squared, this would use up 4m squared from the 3m squared. So not n squared, n plus 2m. N plus 2m squared minus m minus 1 squared equals to minus 1. Oh, okay, fine. So that's just the other way around. M minus 1 squared. That just means that this is 0 and 1, right? Okay, so yeah, never mind. So this is 0. This is plus or minus 1. It says maximum possible, so I think that's where they're being sneaky. Maximum possible, however, maybe not that sneaky because it's just plus 1. So if I add them together, n plus 3m minus 1 is 1. So n plus 3m equals to 2. Yeah, this is saying that m equals to 2 and n is minus 4. You can just do a quick sanity check to make sure that we haven't messed up, which I think we have not messed up. Wait a second. Let me just check. M is 2, n is negative 4. So this is 12 minus 32 plus 16 plus 4. Okay, yeah, so that is indeed okay. Bit rusty, right? So not as fast as I'm hoping. I think I need to speed up. Okay, question 7. What's the minimum possible value of a such that this has two negative integer roots? Vietas tells you that product of roots is 2024. The sum of roots is negative a, and the sum of roots is negative a, which means a is positive. So a is going to be positive. The question is, can the sum of roots be negative 2? Most certainly not. In fact, this will not even be real roots. Whereas if it is 90, 2024 is 45 squared minus 1, which is 44 times 46. So the sum of roots can be negative 90. Question 8. Alice, Bob, Charles, and Diana each bringing a dog. Them and their dogs sit around a round table. So I assume humans are distinct and dogs are also distinct. They want to sit next to their dogs. And also Alice and Bob would like to sit next to each other. Okay, so I'm going to just copy this over into the Word doc as well. Okay, I must remember that I can reflect, right? Reflections are considered different, but basically rotations are the same, so I can put Alice and Bob next to each other first, and I will just put a circle A and a circle B to mean their dog. So these are fixed, and then there are 4 more positions. In the 4 more positions, Charles and Diana would not like to sit next to each other. Basically, there are 2 ways to decide on which one is Charles and which one is Diana plus their dog. There are just 3 out of the 4 possible combinations that are okay, one of which isn't, that they are next to each other. So there are 6 ways that can work for them to be next to each other. And also now the fact that these can be reflected over. So I'm seeing it as 12 ways. I'm very uncomfortable about saying this, but I think that I've not messed up anything. Continue. Question 9. Compute this. Okay, so tangent inverse minus tangent inverse. Now, none of these are special, but I can regroup them . Now I know there's something true about these, but I don't really have time to check what that is, so I'm just going for these two things, and how I'm going for these two things is just to take the tangent of them. So the tangent of these two would be this. This is 5 over 14, this is 15 over 14, this is 1/3. Okay, so actually I don't need to simplify that down. I just bring this down here and it will become tangent inverse half plus tangent inverse 1/3. Famously, this is equal to, I think, pi over 4. Let me just confirm by taking the tangent of this. That is indeed 5/6 over 5/6, which is tangent inverse of 1, and tangent inverse of 1 is indeed pi over 4. Okay, how many 4-digit palindromes are divisible by 99? I know this because divisible by 99 is 9 and 11, and all palindromes are always divisible by 11 using the divisibility test. So I only need to check for 9. And when I want to check for 9, the last 2 digits are all that matters, because I'm reflecting over and 9 is the digit sum. So the last 2 digits can be everything from 09 to 99 except for 90, because if you were 90 then the first one reflects over to 09, which I do not want. And so therefore that would give me 10 options for palindromes, and just nice, I'm on the 15-minute 10-question pace. Okay, question 11. This is sort of a Pythagoras pattern thing where it's just going east, north. What's up? Up and north are the same thing. Okay. So it goes east, north, up, west, south, down, which is this feels like this just trying to make you confused, right? I always say that the Americans have a fairly good sense of humor when it comes to Olympiads. I'm not sure if everyone enjoys it so much when you're doing it, but hey, it's kind of fun. Okay, so 700 yards in total doesn't go that long, so I feel like I can actually just draw it. So east 1, north and up, then west for 4, south for 5, so it came back, but down again. Okay, so the net for these is just that you have gone 3, 6 here. The same thing again the second time. I should probably write -3, -6, right? So east for 7. I should not draw it, I'll just use now north for 8, and then up again for 9. So all the way until 411, and then after that it will go west for 10, and then after that it will go south and down for 11 and 12. Yeah, okay, so just confirms that it basically goes like this. We know that if you add from 1 to how far do I go? 1 to 12, this would be 78. So there will still be another 13 yards east. This is very time consuming. And then after that it goes north, but it only has got 9 yards left. So as far as I can tell, if I've not made any calculation error, it's the 7 minus 12 is the furthest that it has reached. But this seems to be a little bit weird because 7 minus 12 does not seem like any of the options would correspond to the distance, because 7 minus 12 is square root of 193. So I'm not quite sure what's happened there. Let me just jump over it and come back to it later. Question 12, parabola y equals x squared minus 1 and x squared plus y squared equals to r squared intersect in k distinct points. Which of these is not possible? Okay, so graphical, I like this for the purpose that I don't even really need to copy the question down. I just need to have y equals to x squared minus 1. Sorry, minus 1, 0 is on the other side. So I can have 0. I know that if I were to take the point that is closest to it, I'm pretty sure that the options are 0, 1, 2, 3, 4, right? I know that I can get 3. And I know that it will always be even otherwise because it is symmetric about the y-axis. And so therefore, the only time where it is odd is because it's intersecting there. So 1 is the thing that is not possible. Question 13, it says minimum possible f when divided by 5. I know this is just the 1/7 looping question. Right? It's the 1/7 looping question where it's your 142857 looping around. I'm just a bit concerned because it asks you for the minimum possible f. So I need to be careful, because my thinking was immediately that it is 142857 times 5 is 714285, right? This is my immediate thinking. I know it does work, and I know that it gives me f equals to 7, but let's just confirm it. So how I confirm it, I'll let this block A, B, C, D, E be x, and then this thing be y. So 10x plus y, I should just call it f, right? Why am I changing it? Never mind. A 100,000 y plus x. Maybe I write it like this, which if I am, what am I trying to do? Okay, I will put a 10 and then I'll subtract it off. Now because I know that this is 7 times 142857, right? And x is a 5-digit number. 142857, as far as I know, is prime. I never actually checked that. Is it prime? No, it's divisible by 3. Okay. 47619. Is that prime? Oh bother. That's also divisible by 3, right? Okay. Time to divide again. Is this divisible by 3? How many times is this thing going to be divisible by 3? Oh dear. This is not divisible by 3, okay. This may not be the best way to do it, right? I feel like guessing at this point that it really is 7, but I will just pause for a second and just think again. Now, because of the fact that actually in this case, the last digit here is E and E. So if the last digit is E, I know that E cannot be 0. So if E were some other thing, for the last digit to be the same, it means F minus 1 times E ends in 0. Does it work if F is 6? So it's F equals to 6, or I do need the multiple of 5 to come here. Right, F cannot be 1. Now E is 5, then I don't need to go through all of this nonsense. I'm fairly sure that what we have down here is already correct. So what about if F equals to 6? Is there any issue with F equals to 6? Which is what I call Y down here. Let me see. If E is not 1, I should just now do the thing I did just now, right? So I can do the same thing that I did earlier, except that now I know that yeah, and that's not going to work. Do I have anything else that is ending in I need 10e minus 1 to be a factor of that 9999 times 6. Do I have any? How about, yeah, E is a 5-digit number. So no, E is not a 5-digit number. E is not a 5-digit number. X is a 5-digit number. E is a digit. So E is 1 doesn't work. Does any of 19, 29, 39, 49 and so on look like a factor of this? I don't think so. So in order to save some time, I'm going to just make the assumption that F was really just 7 and I've just been wasting a lot of time. We will see. Oh my, I've been really slow. Question 14. Which of the following numbers is closest to this total here? They can be combined. For question 14, we have this pile of logarithms. I do need to write them out though. Yeah. Now I did not do what I normally do for these papers, which is that I take one glance through, but I realized that taking a glance through it would have helped because this is just quite evidently a difficult paper. And so it's a difficult paper, which means two things. One is that you have to be quite willing to guess and speculate, and two, you should be in a lot more of a hurry than I am. Okay, so it just combines. The last one is 104/3. Now, which of these is it closest to? Well, I have a margin of 10. Right, so that's a good thing. But how many things are there here? There are 49 terms. Okay, no, I think I can just bound it roughly, because I don't think that this cancels that well. So 104/3, 106/5. Essentially, I'm just trying to get their integer parts roughly, right? Of the floor of the log base 2 of them. So this is about 5 point something, 4 point something. This is going to be 15 point something, so it's about 4. Once you are here, this is times 12, so this is about 3 point something. There's a few more trees, all the way until it ends up being about 8 times. So then it continues on all the way until it's just 4 times, which would roughly be when I'm at 33, 134/33. And then after that it continues all the way until it's about 1. So a lower bound on it is that this section here, of which there are 34 of them, if I lower bound it using 1, and then everything I can lower bound it as these up to here is all 2's. Between here and here I've got another 10 more 2's, and then a bunch of 3's. Now this is a lower bound, this is not a very good estimate. That will give me 13, 22, 42, and 76. Now this is a lower bound, but in reality most of these are going to be well closer to the other end. So I think this is a lot closer to 95, which in retrospect is probably true just because each pair multiplies to approximately 2 to the power of 4, I guess. Something like that. Well, I don't really have time to confirm it, so I will just speculate again. Okay, 15. Ant on the coordinate plane is trying to crawl. The plane has a triangular hole. So you don't want to fall into the hole, you want to go around it. The AMC10 felt a bit too easy at the front, and this one feels a little bit too hard, right? In terms of being time consuming. Now 6-2 is on the line. 4-1 is, So 3 ones on the line, 4 ones below the line, 2 ones on the other side of the line. And then there is this triangular hole that is blocking the path from 0, 0 to 9, 3. Now if I'm trying to go from 0, 0 to 9, 3, I believe I should just compare these two paths. I can't go through the hole, but I should only go in straight lines. There is never a point in which I should not go in a straight line. Yeah, so I'll just compare those. This is the root 5 plus root 53, and the other one is the root 17 plus root 29. How do I compare the two of those? Easily. Now, oftentimes the AMC has put the options in ascending order, but here I'm not sure how to quickly check this. Let me just do it to 1 decimal place and hope that's enough. This is 4.1, 5.4, 2.2, and 7.3. You've got to be joking there. They're really close, aren't they? Okay, I'm not going to do it to 2 decimal places. How do I compare these two? Square them both. 2 times the product of these two, which is 493. Product of these two is 265. Move this over and divide by 2. I've got this root minus this root versus 6. This is 22 point something. And you've got to be joking. How tight is this? Alright, let's just square it again. I hope I've not messed up the order at any point in time, otherwise that would be very annoying. 16 versus root 265. Okay, so the one on the left was smaller all along. Well, I don't know. They have scrambled the order of answers recently for the AMC, but previously it used to be in ascending order. Okay, question 16. Going to just copy them directly into the Word doc. There is no way I can do some of these mentally anymore. Problematic keyboard, a 10% chance that it has a hit, has 2 hits, including the backspace key. Wow. So I think this is actually one where you just need to focus on the single letter and the double letter, how long it takes to do it, and then you add the whole thing up, right? So to get one letter, there is a 90% chance it works. There is a 10% chance that now you need to backspace. So normally we write it as a self-referential equation, and I think that's probably good here. Now, if you have a 10% chance it appears twice, there is a 90% chance that it just works when you have backspaced it. And then there is a 1% chance you're back where you started. Okay, so 0.99x equals to 1.08. X equals to 12 over 11. Does that make sense? Well, I mean, most of the time with one key you are fine, right? So we will see. I'm not sure if I have this right. Now, the other one is that you have got to key in twice. Right, so if you want to get a pair of identical letters, how long do you need to get to here? Now there is a 90% chance that you get to one letter, and there is a 10% chance you get to where you want if you're already there. If you are in the middle, you would press the key again. There's a 90% chance you get to where you want, and then there is a 10% chance you overshoot. And if you overshoot, you will press a backspace. There's a 90% chance it gets here, and a 10% chance it goes back. So let ABC be the expected number of key presses you need in order to get there. Sorry, I need to zoom out. So there's sorry, this just 1 plus 0.9b. This one is 1 plus 0.1c, and c is 1 plus 0.1b. This 2 tells me that my b equals to c equals to 10 over 9, and if b equals to c equals to 10 over 9, this tells me a equals to 2. That doesn't seem to make any sense though, because how many single letters are there? S, U, E, U, F, U, and Y. So there's 6 singletons, and there are 3 doubles. At this point, I'm saying that you will need to have 6 of the 12 over 11 and 3 of the, it can't be 2, right? I mean, how can you take average of 2 press? Actually, it can be average of 2 for 2, right? Because sometimes you get a shortcut. Okay, let me check back the first one again. So I'm saying that for X, there is a 0.9 chance that you land where you want immediately. With one letter, there's a 0.1 chance that you overshoot. With the 0.1 chance that you overshoot, if you press backspace, 0.09 chance that now you've landed within 2 turns, and oh yeah, this is not 0.01x, this is 0.01x plus 2. Okay, so that explains why it looked a bit weird. This would be 20 over 3 plus 6 is 38 over 3. I see that appears as an option. two circumcenters. Midpoint. Now, O is the circumcenter of ABC, P is the circumcenter of ADC, means that it's still going to be that they are both on the perpendicular bisector of AC, but P is now going to be down here. And there are lots of right angles everywhere. I'm just thinking, what is the fastest way that I can get to OP? I guess just this is 2, so I want to find this height. And in order to get heights, I can just do a whole lot of length bashing. So I'm going to do that as mindlessly as possible. Area using Heron, 7, 5, and 8 semi-perimeter is 10. That means that your R equals to 7 over root 3. This height here, 7 over root 3 squared, 49 over 3 minus 4 squared is just 1 over root 3. Now for the ADC, how do I find what I want? I want this new circumradius. I guess if I want the new circumradius, I need AD. And for AD, I can just use Stewart's to get AD, or Apollonius. Square root 21. Why do I want AD? I wanted the the circumradius of ADC. I know that the area of ADC is half of ABC. So PD is root 7. So that means that this height down here is root 3. That other height there is 1 over root 3. So your OP is the square root of 2 squared plus root 3 minus 1 over root 3 squared, which root 3 is 3 over root 3, so this is 4 plus 4 over 3. This is the square root of 16 over 3, which is option B. I'm sure there's something better, but this is how it looks like when you are scrambling. Question 18, unit diamond, parallelogram formed by two equilateral triangles together. How many ways are there to tile 12 unit diamonds? These are all small options, so it's mainly just about observation. I think you can almost list. Unit diamonds. Okay. I guess I can draw a regular hexagon, chop it into 6 equilateral triangles, and then chop it further. This is 24 as intended. Rotations and reflections are considered as the same. My gosh, how exactly is this easy to count? Okay, I guess I'll look at if for all the edges I put them aligned with this, then this is going to be just one way. So all of the corners of your hexagon, you just put the hexagon there, the diamond there. Now let's say if I put one of them like this, then this is all forced. So I can carry on like this. Once I'm here, it is fixed. So this is another way. Reflections also considered the same. Okay, so if I just combine them here, there's so many ways, right? Okay, let's see what actually happens when I do this. Now what happens when I'm doing this is that actually you've just got 3 of them which are aligned with the corners and 3 of them which are not. Can I split cases like this? Okay, maybe I should. So I've already said that if you put one of them like that, it is forced. If you can't put 2 of them in this pattern next to each other. So the other one was 3 of those. How about if I only have 2 of them in that way? Can that happen? Right, so I can have 2 of them that way. So 2 corners which are split this way. Can I have 2 opposite corners split this way? I also can have 2 opposite corners. So I've got, can I have none of them that way? I also can. Right, so I'll call this sort of a split. I can have no split. I can have 1 split. I can have 2 splits in 2 ways. And I can have 3 splits. So that's 5 cases. I think now I'm going to do what we should do in a contest time with, wow, just 20 over minutes left, which is just to scroll through everything and just see what looks like a question that you would want to do. That would differ for you, but that's a lot of geometry. I have something in front that I have not yet touched, right? So, not touched, this sharp thing. Let me understand what's going on with north, south, east, and west, and up and down. Okay, maybe I'll just go back and check my workings for what I had earlier and just see, because I don't really have time to calculate all of that again. Still don't really understand what's wrong with what I've done, so never mind. I'm looking at question 19, and I think that is possible to do, so I will just carry on with it, because it says parallel lines, you're dividing into equal slices, so a lot of similar triangles and a lot of ratios that may be good. I don't even know which one's the right angle. It doesn't even say that. Well, let's just assume it's this first. By 5 slices, and then 4 intersections of these parallel lines with AB. Oh, it splits it in the ratio of 5, 4, 3, 2, 1. Okay. JK. So it's 5 is to 4 is to 3 is to 2 is to 1. And the perimeters of the 5 slices only have 3 distinct values. This is strange. I think I know how to do this, but it may take a bit too long, so let me just look around for something else. This is not as nice as I thought it would be. I think I know how question 20 works, so I will use that. So the trick for getting a closer one here is that you use continued fractions. So you want a closer one than 3 and 1 over 7. So something between 3 and 1 over 7 and 3 and 1 over 7 and 1 over 16. you would need to come up with 3 and 1 over 7 plus something that is between 1 and 1 over 16. Which I guess you can use. No, you can use anything like 1 over 17. Will that give you something simpler? Well, that will not give you something simpler, will it? Let me just check. Not simpler. This gives you 120. What will give something simpler? Wait, does it need to be less than 100? It asks for something closer. Does it still need to be less than 100? Or is this good enough? As far as I know, this is the best you can do, right? So I'm just going to take it as this is it and the answer is 0, and if I have made a mistake, I don't have time to rectify it right now. Okay. I also think I know how to do 22, so when it comes to these sorts of things at the end of the paper, you should be just looking at what is your pre-existing knowledge, which is not always going to be the same for everybody. Right? The reason why I want to do this is that AN is literally just V2N, which is going to be N minus S2N, where S2 is the sum of digits in binary. Now, n minus an, therefore, is just S2n, and therefore we're kind of asking what's the average sum of digits in binary from 1 to 1024, which is actually going to be this is 1, this is 1024. Now, in here, if I were to just pad it with zeros, these are, because this is 2 to the power of 10, these are 10-bit binary integers. So 2 to the 10 of them with 10 bits, half of which are ones. But then there's one more 1 down here, which is going to give me just, this is the sum. And so therefore, if I do it at random, it means I divide by 1024, I get 5 and 1 over 1024, which is 5.001. So I think the option I should pick is D. I do also apologize that there is some loud renovation works that's going on next to me, which is not helping, but we can try. Really don't feel like doing 3D geometry if I can help it, just because of the time it takes to draw. On paper I can scribble out something, but now that I'm trying to do it on a laptop while showing my work, that takes a while, so I'm going to pick the number theories. Usually it's a bit easier. 6 5-digit prime numbers such that they have a difference of 16. That's, what's the maximum possible value? Okay, so this is talking about mod 3, mod 5, and mod 7. Now, if let's say that I just start and call this n and n plus 16. Now, these are all the odd numbers. These are all the odd numbers which I can possibly choose. Now, mod 3, these are going to be together, and so these cannot be 0 mod 3, and also that these three are all together, so they also cannot be 0 mod 3, so it confirms that n plus 2 is the 0 mod 3. Now I can do mod 5. Now I can just trust that it is possible. I'm not going to find the 5-digit numbers, I just need to avoid. So mod 5, it means that this 2 I have to avoid. This has to be avoided. And so, okay, maybe I should write it as, so n is, actually I have n plus 16 is the P6. I should have written it as, that is n. Never mind. The P6, if this is 2 mod 3, and mod 5, what I'm saying is that it is not 0, and it is, so n plus 16, P6 and P6 minus 16 are not 0, so it's not 0 or 1, it can be 2, 3 or 4 mod 5. And then for mod 7, it just has to be not 0 and not 2. Now I want the smallest possible remainder when divided by 105. This means either I can have 2 or 8 or 14 mod 15. And I'm just seeing that 8 mod 15 seems perfectly fine already, like is compatible with this. So 8 mod 105 seems okay, but let me just check. So the problem is that if I pick so if let's say I pick this is 8, I need all of these to be prime. Okay, so I need these 6 things to be prime because these 3 are already not. Okay, so that's actually what's going on. I was a bit silly there, so I need to make sure that all of these are not prime. So it means that I should probably have written it this way instead. 6 minus 10, P6 minus 12, P6 minus 16. So I already know that it's 2 mod 3, but now I need all these to be prime. So it cannot be 2 or 4, it has to be 3 mod 5. And then mod 7, I know it cannot be 0, it cannot be 2, it cannot be 4 also, it cannot be 6 also, it cannot be 5, it cannot be 3, it is 1 mod 7. Okay, so actually it is very constrained. This and this gives me wait, so it's still 8 after all that time. It's really just great, should have just written 8. Okay, so it really is just 8. if I have not miscounted anything. Okay, what do I think I want to do? Regular hexagon sounds good. Let's do the regular hexagon at question 21. That is not too hard to draw. So if I've got 5 minutes left, I think that's the best shot I have. ABC are on these three, and they are all equilateral triangles. Now this is basically like rotationally symmetric. I believe that's what I need to go for. So I believe this is what's happening. This okay on ray JK, ray FG, and ray HI. I'll just redraw this a bit better. I've got to have something that looks like this on the extensions of those three things. Wow, they're supposed to be parallel to each other, the sides, but I don't really have time to fix that. So I'm just going to think about this a second. So it basically means that, what does this mean? If this is 45 degrees, I mean this would have been here if I wanted 30 degrees, right? And I'm rotating it upwards slightly. Which means that essentially it is a 15-degree rotation upwards from there, which I'm not drawing it perfectly right, but that should be enough for me if I wanted to get the size of this triangle. Now if ABC is an equilateral triangle, and I'm also drawing another equilateral triangle here of like OGH. OB would be 1 over root 3. I should be able to get the side quite easily. Just a little bit of, yeah, just sine rule will do. I can just call this thing here P and Q. P over sine 45 degrees is root 3 over sine 60. So this would be root 2 over 3. The other one is with sine 15 degrees, which is root 6 minus root 2 over 4. Which is root 6 minus root 2 over 6. Yeesh, this is not nice. Actually, this is not terrible. you add them, you get this root 6 plus root 2 over 6 is the side length of that triangle there, but what exactly am I supposed to do? I've got 1 minute left. Okay, so there's definitely a homothety. It's symmetric. There is definitely a homothety, and it is just scaled up. What is the scale factor though? I am not sure. Now that would depend on if I wanted to draw a big equilateral triangle around it, or a big hexagon around it. Okay, I'm really not sure how this can be done in the time that I have, so I will just do a quick scan through. I guess, first of all, this is really hard. As an AMC12 paper, this would be harder than almost all of the recent years papers. Second of all, you will see that I am not doing this with any prior preparation, right? Lots of scrambling, as has been advertised. This is how your AMC should look like. A lot of rushing, a lot of unintelligible scribbling, and probably 1 or 2 careless mistakes are fine. Let's see how it looks like. Well, that means I have a few mistakes, which I'm not surprised by. I made some guesses. Let's take a look. It's 3D. Up. This is not 2D. I assumed that it was 2D, it was 3D. Okay. I have no complaints then. That would make the question a lot easier, but I didn't really remember that the ocean has 3 dimensions. Ah well. Never mind. F can be 6. Okay. Well, they would have taken too long to calculate, so I have no regrets over making my guess. My estimate was fine. It could be simplified roughly. I kind of knew that, but this is a bunch of estimations still. So that one is okay. This one is okay. This one turned out to be correct. This is correct. Oh, they really call this split. Okay. So that's 6. Okay, so I missed 1 because I think I identified 2 cases to be the same that were really not the same. I don't really know what I was saying at that point in time. I'm also okay. So I think for a competition setting, sometimes you can just concede that, you know what, this is the best I could do. I didn't do this one. This one, yep, that would have taken way too long. So I am also okay with that decision. Oh yeah, okay, so for this one I made a mistake because I'm realizing now that I tried to find something that is between the two when I should be finding something that is just closer to the 335 over 113. So that was my mistake when I was in a bit of a rush. I didn't really think through it carefully. I don't need it to be in between. Right? I don't need it to be in between, I just needed it to be closer. So what I did was for in between. You can adapt the method to here, but it is not exactly the same. I did do some of the correct calculations and I did have the correct understanding, but this would also have taken far too long, so I have no regrets for question 21. I did get the 2 so-called harder questions I wanted, which is 22. This is an explanation that amounts roughly to what I said about the Legendre's formula. And 24, I sort of did the same thing. This is just written out in full. So let's take a look at this. How does it look like? I need projection on the plane. Okay, so I again do not regret the choice of skipping this. The 3D geom would have taken a bit too long. And there are so many cases. Didn't even read the question, right? Maximum possible S, my goodness. Okay, I'm glad I did not do this question as well. This is not a very realistic AMC question. I'm sure that given enough time, it can be done. Okay. Comments. First of all, I am not giving myself as a perfect example. I'm no longer taking it in competition. I am teaching, and that means that I do not have the need to be in a competition fitness and stamina, so to speak. If you're taking the contest, obviously you are in a slightly different position than I am. This is hard. I am handicapping myself by trying to talk a lot, at the same time also showing some of my steps a bit more carefully, but I'm happy personally that it seems that the only so-called careless mistakes I made were, one, I did not realize the ocean was 3 dimensions. This is going to happen to many of you. Something weird like this, just let it go. It's fine. No one needs you to get a perfect score for the AMC. But if you're aiming for it and this happens, just let it go. This one is sort of a concession I made. Strategic guessing is something that I'm okay with. I did specifically say that F could be 6, but then I just couldn't see it, and there were too many. It says for each case we derive the digits from right to left and check whether they're the same. That will take too long. So strategically skipping is also something that is okay. And then something like counting, you have to just be prepared that one of your counts is quite possibly incorrect. Okay, so overall, I think this is a very hard paper. If the paper were to look like this, I think very realistically that the AIME cutoff could be something like in the low 80s, because the first 10 questions are still not so bad. So the low 80s quite possible, and then you'll be looking at 109.5 like what I have is not going to be too far from a DHR already if the paper looked like this, because the questions behind are substantially harder than ones in front. Okay, so feel free to try the questions. Open up the link if you want to try it. By now, I guess it's not really much of a proper mock paper, but you can just read the solutions for yourself. I'm not going to go through that because that will make this video far too long as it is. It's already approaching an hour and a half. Okay, so thanks for watching. Thanks for seeing me scramble through all of this, and hopefully this gives you a realistic depiction of how it actually is for someone to be doing it. It doesn't look very beautiful, it doesn't look very elegant. It usually looks like a big mess like this. All the best for the coming AMCs, and see you again soon for the next video.